Hi, in this video we will talk about a new capability added to Era that makes Era more durable and highly available for our customers. In order to understand this new capability, it's essential to understand Era's current architecture. Era runs as a user VM on a Nutanix cluster. The VM is comprised of two primary elements, the API server, which is backed up by a Postgres repository. This repository is used to store relevant information like customers' databases, clones, time machine, snapshots. This repository does not store any of customers' data which runs on their databases. However, the metadata it stores in form of entities is crucial for Era's operation and to provide a composite picture to its customers. This architecture has its pros and cons. It's a simple architecture and consumes the least amount of resources on a customer's cluster. However, it has a few single point of failures, especially the Postgres repository. In case the Postgres repository fails or goes down, the Era service is essentially unavailable. More crucially, since the Postgres repository is a single instance, this architecture is vulnerable to permanent data loss. In case the Postgres repository goes down and is unrecoverable, the metadata related to the customer's entities is lost forever. As a step towards providing a zero data loss service to its customers, Era now offers an alternative architecture to its customers. In this new architecture, the single instance Postgres repository is now replaced by a clustered Postgres. It's a 3-node cluster front-ended by a couple of proxies for redundancy. The Era API server connects to these Postgres repositories via the proxies. Any entity data that is inserted or updated by Era now gets replicated across these three Postgres nodes. One of the Postgres replicas is a synchronous replica, ensuring that not a single transaction is lost in case the master fails. This architecture also provides higher availability. In case the Postgres master fails, we automatically fail over to the synchronous Postgres replica, hence keeping the Era service alive. Apart from providing redundancy and data durability, Era also utilizes these replicas to improve query performance. The master Postgres instance is used for all write queries. However, the read queries are now redirected to the synchronous replica. Now, essentially, we have two Postgres instances replying to our queries instead of just one. This architecture has its shortcomings as well, with the main shortcoming being the added resources it consumes on the Nutanix cluster. We realize not every Era customer requires this elaborate architecture and the kind of availability and durability it provides, especially at the cost of additional resources. As a result, this architecture is an optional feature that the customers can enable. Out of the box, Era still ships as a single VM solution, but additionally, customers could go into Era and enable this architecture. Let's see how this can be done. Under the administration section, we have a new section about the Era service. This gives you a high-level idea about Era's current topology. We have an option here to now enable high availability for Era's repository. As part of user inputs, we require a network profile with static IP configured to create these Postgres and HA proxy instances. The user can also optionally provide a prefix for the VM names that are used for these additional instances. Once a request is submitted to enable HA for Era's repository, Era creates a new Postgres clustered database. As part of the operation, it migrates the current entity data to this new cluster. The Era service may be unavailable for a few minutes while HA is being enabled. Once enabled, the Era's topology now looks like this. As you can see, we see additional VMs corresponding to the Era's repository, which is Postgres, and the HA proxies. The zero data loss and high availability feature will be available with Era's 1.2 release. This concludes our video. Thank you.